let's take a look at a couple other properties that we can use to help us with simplifying radicals. The first one is the multiplication property, or the product property, where we can take a value and break it up into two individual radicals. So if you look at part A, you can see that we can break 18 up into 9 times 2, which then can break up into two completely separate radicals. Whenever you use the product property, what you're really doing is looking for perfect squares. So you're going to look for perfect squares embedded in a number. So if we look at 18, we know that that has a number of different factors. You can break up into 6 and 3, 18 and 1, and also 9 and 2. So we would be looking for the factors that would include a perfect square, and that's why we would choose 9 and 2 so that we can break those apart. Now, keep in mind, the product property can go both ways. So if we have a 5 and a 10, we can actually put those together, which gets it all under one radical. Now, the only reason we would really want to do this is if we see that the potential product could be broken down into something different that actually has a perfect square, and in this case it does. The 50 can be broken up into 25 and 2, which has a perfect square of 25. So go ahead and let's take a look at sample problem number 2. You've got 4 there. Let's go ahead and pause the video and take time to do that real quick. Okay, so if we look at this, square root of 75 has two factors that has a perfect square. One, we have 25, which is our perfect square. So if we break this up, I'm going to have 25 and 3, and I can break those into separate radicals. And the square root of 25 is 5. The square root of 3, however, cannot be broken apart any farther, so we would just leave it as 5 times the square root of 3. Now this is simplest radical form, so we would stop right there. Square root of 27 can be broken up into the square root of 9 times the square root of 3, which gives me 3 times the square root of 3. The next one was a little different because it has a variable in it, but if you think about this, 9 is being multiplied times x squared, so we can actually break those apart into two separate pieces, or two separate factors, and each of them is a perfect square. 9 is a perfect square of 3, so 3, and x squared, when you take the square root of x squared, the square root and the square actually cancel each other out, leaving you simply x. So we have 3x remaining. The last one here is one where the 2 and the 8, neither one of them are perfect squares, but if we put it together, we can see that it's going to give us the square root of 16, which if we've learned our perfect squares, we know that that equals to 4. So these are all good examples of the product property that you could use and see in different ways.